And interestingly, we are at 45 minutes, which is a little bit longer than I expected it to be. But the good part is, now that we know how to catch the axis event, doing the work with it is quite simple, because it's just like our old code was. Let me take you through a couple of examples.
When you say old code, you're talking about when we were doing just keyboard
so,
mouse inputs.
Previously we had code for like the keyboard and mouse, and we used vectors to do movement and stuff like that, where we're doing the same vector calculations. We're just getting the vector from a different place. We're getting it from the joystick this time. I'll show this. Let's look at the player. Okay, so the player has a piece of code called on left joystick. Now before we look at that, let's go look at the way we used to do movement. So movement done for the player was with this field called move Y. It said that if move Y was 0, you're not moving, don't move. But if move Y was anything but 0, move, and move in the direction of the sign of that value. In other words, if it's minus, then well, that's not exactly correct. This is what I get. Originally in this game, we allowed omnidirectional movement from up, down, left, right. And then I eventually restricted it to just the y-axis, moving up, which up in the world is minus y. So if move y is -1, that means we're moving. So if we look up here at the section called keyboard and mouse, we'll see that we were listening for the W or up key, and then when the phase of that key was down, in other words it was pressed, we would set move Y to -1, and then when the key was lifted, we would set it to 0. So press W or press up, and it would move in the forward direction. That's the way the player code works. If we push the key, whatever direction the player is facing, that's the direction it moves. So similarly, for the controller, we wish to move forward if the length of the controller vector is greater than 0.7, which is what I was talking about earlier. So we're going to get this event called on left joystick. It's going to contain a vector. The first thing we do is I normalize that vector, and I do so. No, I do not. I'm sorry. I look at the length of that vector, and if the vector is greater than 0.7, length greater than common move length, then I set the move Y value to -1, and that code feeds into our previous code with no changes and tells the prior code it's time to move forward. If, however, we get a joystick event and the length is less than the move length, we set move Y back to 0. So that's all this code does. It's a very small piece of code that is actually quite a bit shorter than the key input and does one thing. It looks at the joystick event and says, how long is that vector? I need to move forward. But the question then is, how do I know how to face? Well, you'll recall that I said that the way facing is handled in the game was handled previously to the controller is we looked at the position of the reticle. So I wanted to retain that. So I added to the reticle a left joystick listener, on left joystick. So it too listens for this new event called on left joystick. But before we look at that, let's go ahead and scroll up a little bit. And we have this section here. It says, if input style is keyboard and mouse, instead we attach a mouse listener. Now the mouse listener, if you recall, basically moved the reticle graphic to be in the same position as the mouse. And then future code would look at the position of the reticle and decide what direction the player was supposed to be facing. So what we want to do this time is we wish, in the case of using the controller input, we want to listen for a left joystick event, figure out what angle that vector is. So what that means is if you push the joystick up, that is 0 degrees. If you push it to the right, that's 90 degrees. Down is 180 degrees and left is 270 degrees. So using the angle of the joystick, I create a vector that is based on the angle and then multiply that by the length of the vector and the reticle distance. And then, it's easier if I run this. When I move the joystick, it generates a vector that I then add to the center of the screen. And the reticle, I know this is a little bit hard to see because you're moving, so let me get this guy up in a corner. So now we can't move. You'll see that the reticle, which is probably a little bit hard to see over the forest now. Let's do this. You know, it would help if the enemy wasn't chasing me all over. Heck. But the reticle is basically following the angle of the joystick, and we convert that into a vector, a distance vector, and add that to the center of the screen. And so, really what we're controlling here with the joystick is just the position of the reticle. Everything else in the code is the same, and at this point, the code will look at the position of the reticle and say, oh, it's off to the left, so the character needs to face left. Now it's off to the right, the character needs to face right, down, face down, etc. And so we extract the angle by converting the vector into an angle. I do a thing called normalizing. Now the problem here is that the vectors that come in may equate to some kind of weird angle, but I want to keep my angles between 0 and 360 degrees. So I have a piece of code in common that looks at the angle and says if it's a negative angle, really what that is let's say like negative 45 or negative 90 degrees. Negative 90 is equivalent to positive 270 degrees. They're in the same position. And so what this code does is it says, I don't want negative values. I just want a value between 0 and 360. So if it gets a negative value or a value greater than 360, convert it so that it's equivalent to the same angle, but now within the range 0 to 360. And what that lets me do is it lets me do consistent calculations. There are cases where when you're dealing with angles and you're trying to make a decision, that you're thinking, okay, is this value between 0 and 360? Then I'll do this. When in reality, you get this weird 720 degrees. Well, that's the equivalent of 0 degrees. But if your code wasn't written to handle it, it's not going to work. So instead of dealing with that decision all the time, I simply normalize angles when I'm working with them. And so I have this little library which you can look at. Well, helps if you remember what you're looking for. Norm wrote. And this little tiny piece of code will normalize the rotation of a numeric value. And let me just check here. We'll also update, so for example, let's say you've rotated a display object by 720 degrees, but you'd like to clean up the rotation to make it 0. 0 and 720 are equivalent in most cases. So you can just pass in a reference to the object and it will clean up that rotation for you. So if the object rotated 360 degrees and then an additional 45 degrees, and you really wanted it to have 45 as the rotation value, you could just pass it into common norm rote, and it would do the little magic on there and then change it to 45. So, all right, I've gotten off track here. So we're listening for left joystick. Left joystick in the reticle here does one thing. It positions the reticle relative to the center of the screen. It does so by getting the angle, converting that angle into a useful vector, multiplying that vector by a length, and then adding the resultant vector to the center of the screen, and we're done. All the